Alright everybody, this is alternating series, more tests. Day number, I believe this should be day number 6. Yeah, it should say day number 6. We're going to talk more in depth about radius and interval of convergence. This right here, watch the outside of the interval, that's just check the endpoints. So that's check endpoints. And shift of center, that's something like if you see something like that. All right, this here would have an interval or a radius of convergence of 1, but the center of it will be at 2. So, yeah, let's get started. Okay, so let's find the radius of convergence for the following. Anytime you're asked to find the radius of convergence, R, right, you are going to employ the ratio test. Okay, the ratio test applies when finding the radius and then therefore finding the interval. So let's take the limit as n goes to infinity of use of n plus 1. Remember, with the ratio test, we use the absolute value. In this case, it won't make that much of a difference. So that's the n plus 1th term. There's the nth term. When I take the limit of that as n goes to infinity, that would be the same as the limit as n goes to infinity of x to the n times x over x to the n, which of course would be equal to x. When using the ratio test, we want whatever this is to come out to be less than 1. Okay? Therefore, our radius, r, in this case, right, the coefficient of x there is 1, therefore the radius of convergence would be 1. Now the interval of convergence, if I were to drop those absolute values, the interval of convergence is going to require us to then test these endpoints, right? Because potentially we could be, that interval could include those endpoints or include one and not the other, or not include either of them. So let's find the radius of convergence here for the second one. Again, absolute value of u sub n over u sub n plus 1, or u sub n plus 1 over u sub n. So if u sub n plus 1, instead of dividing by the other, I'm going to multiply by its reciprocal. And we take the limit as n goes to infinity of that. So this would reduce, limit as n goes to infinity, this would reduce to, it looks like x over 3. Okay, and there's no n evident here, no n present. Therefore, right, what this would evaluate to is x over 3, which we want to be less than 1. Okay, so here our radius is not 1. Our radius, if I get a coefficient of 1 on x, is going to be 3. So r is going to be 3, and our interval of convergence is going to potentially be negative 3 to 3. Now notice that this is centered on 0, right? I got a symmetrical interval here around 0. So the center is still at 0. Again, I'd have to test these endpoints, and I'm going to show you how to do that in a little bit. All right. If, when you use the ratio test, if the limit as n goes to infinity of u sub n plus 1 over u sub n comes out to equal 0, then your radius will be infinite. Any value will work. All right. If the same thing happens except it comes out to be infinity, then no value will work. Therefore, r would be 0, and therefore your interval would not exist. Okay, so just be aware of those two things. Okay, so let's find the radius of convergence on this one. A little bit more algebra involved. So this would be the limit as n goes to infinity of n plus 1 factorial times x to the n plus 1 over n plus 1 to the n plus 1 power. Ooh, that's dirty. Okay, times the reciprocal of the original, so that's n to the nth over n factorial x to the n. All right, let me clean that up a tiny bit. All right, so this would be this right here, the n plus 1 factorial would really be n plus 1 times n factorial. X to the n plus 1 would be x to the n times x. In the denominator, I would get n plus 1 to the nth times n plus 1. Okay, now over on the other side, I don't have to reduce anything. At least I don't think I will. No, I won't. So I get n to the nth over n factorial x to the nth. And we're going to get some cancellation. All right. So this blue piece here, the n plus 1 will cancel with this n plus 1. I'll get x to the n to cancel with x to the n. Okay. That's going to work, I think, for me. Nope, I got one more. I thought I had one more. N factorial will cancel as well. Okay. So let's take the limit as n goes to infinity of x times n to the nth over n plus 1 to the nth power. Alright, so what's going to happen here is as n goes to infinity, we've got our x, we've got our n to the nth. X is kind of like a coefficient of n to the nth. If I were to expand that, my highest power term would be n to the nth plus a bunch of other garbage after it. So this would go to 1. Therefore, it would go to the absolute value of x. And we want that to be less than 1. So clearly our radius here would be 1. And our potential interval of convergence, potential, again, would be that. So let's get on to finding the interval of convergence. Okay, here's an example. For what values of x is this convergent? When it says for what values, that's asking interval. Okay, I'm going to scroll down here and do this one without looking at all this other stuff. So x minus 3 to the n over n. So the summation from n equals 1 to infinity of x minus 3 to the n over n. I'm employing the ratio test immediately. To find the values, I'm going to have to find the radius and then test some endpoints here in a moment. If you haven't gotten privy to what's going on here yet with regards to expansion and then simplification, I'm going to get this times this over this, which will go to this. So what we would use here is the absolute value of x minus 3 less than 1. That tells me my radius here is 1. And my interval of convergence, what I'm going to do is I'm going to write x minus 3 less than 1 greater than negative 1. I'm going to add 3 to both sides of that inequality. So that'd be a 4 and that'd be a 2. So our center of convergence is now at 3. So that there's no coincidence of that right there. So what I'm going to do is I'm going to test x equals 2 and I'm going to test x equals 4. So my original series was up here, x minus 3 to the nth power. So what would this look like if I plugged a 2 in? So if I had x minus 3 to the nth power over n, and x was 2, well, what that would turn this into is an alternating series. That's the alternating harmonic series. I know that that is convergent. Okay, you're allowed to say that by the alternating series test, right? This is the alternating harmonic series. Now, if I plug in 4, go from 1 to infinity, I'm going to get it's not going to be an alternating series, but it is going to be the harmonic series, right? Because the 1 to the n would just be 1 in all cases. So I'm going to get that. Of course, that is divergent. That is divergent, and you could show that by using the integral test or whatever, but I know it's the harmonic series, so I know it's divergent. Therefore, my interval, based on this, if it's convergent at 2 but not convergent at 4, my interval of convergence would be from 2 to 4, including 2 and not 4. So that's how you go ahead and you check endpoints. Now, when we check endpoints, you could have to use any one of your tests. You could have to use the integral test. In this case, we just did it by inspection, but you could use integral test. You could use potentially a ratio test. Any one of the tests we have, the door is open. So let's move on. Okay, another example here. I'm not going to check that. This notation right here with this weird looking bracket, that just means that it's open at that end of the interval and closed on the other end. Okay, find the radius and interval convergence. Notice here that as we do the ratio test, we get 0. Therefore, the radius of convergence is all real numbers, and therefore x can be any value. Right? So our interval of convergence is also all real numbers. Okay, so I'd like to do, let's see, do I want to do this? Let's go on to another. Let's try one of these. Oh, this is gross. Okay, let's do part D here. All right, so I'm just going to get started with the ratio test. I'm going to put down the first few steps here and come back with some stuff written down. Okay, so as you take a look at this real quick, I want to bring to your attention one quick thing. Originally, lightsabers. Originally, this was an alternating series, but once I do the ratio test, that alternator goes away with the absolute value signs. When you look at, so just some algebra to go from step 1 to step 2, right, canceling with n plus 1 and n here, reducing down to 1 here. This term here and this term here as n goes to infinity. Okay, you might argue you get infinity over infinity, and you do. If you employed L'Hopital's rule, eventually you would see that that would go to 1. Therefore, what we get in the end is absolute value of 2x plus 3 less than 1. Now, we haven't gotten this type of inequality, and in this case, you want to be careful. You're not going to get a radius of 1, and I'm actually not going to find the radius right now yet. I'm going to get the interval of convergence first, and then jump into the radius. So let's take a look at this real quick. So if I take away the absolute value, I get this. Okay. And then I'm going to work my way here. Adding 3. So I add 3 to both sides. Make that 4. And then I'm going to also add 3, or excuse me, subtract 3, my bad. Wow. Subtract 3, I get a negative 2. Subtract 3 over here, I get a negative 4. Divide both sides by 2. I get a negative 1, and I get a negative 2. Now I got to test these endpoints, right, as we've done before. So if I test the endpoints, oh gosh, look at that original. Let's test negative 2 and negative 1 up here. This will help me a little bit. Okay, so if I plug in a negative 2, let's just do this mentally. That would be negative 4 plus 3 to the nth. Negative 1 to the nth times that over n natural log of n. Okay, So, oh goodness, not -4. Yeah, no, that's good. -4 plus 3. So that'd be -1. Let's look at this series now. From n equals 2 to infinity of -1 to the nth times -1 to the nth over n natural log of n. Okay, so we want to be careful with this, because if you have two alternators and they both have the same power, technically this is equal to -1 to the 2n, and an even power on that will always make that positive. Right, so technically this is going to be equal to 1 to the nth, right, or just always 1. So we're going to get 1 over n natural log of n. That's if we plug in the endpoint -2. So if we plug in the endpoint -2, we could employ the integral test, but this is going to be divergent. Okay, so that'd be divergent on -2. Let's go back down here, and we're going to leave that as an inequality without the equal sign at the bottom. Okay, so now let's test -1. Okay, so if I plug in a -1, that would make this a -2, which would make this a +1 here, which would keep the alternator. And by the alternating series test on this one, all I got to do is two things, right? Show the limit that as n goes to infinity of the non-alternating piece goes to 0, which it clearly does, and that it'll be decreasing, which it also does. Therefore, by the alternating series test, this end of the interval would be convergent, and that would be our interval of convergence. Now think about this for a minute. Here's my interval of convergence from -2 up to -1. That is a length of 1 unit total, so our radius of convergence would be 1/2. All right, I'd like to touch on number 6, and then we'll call it a day. So if we know that this thing has a radius of r, right, then what that means is that this series, well, we don't need to go there, it's already written there. What that means is that then the absolute value of x is less than r. Now the next step might fool you a little bit, but let's let x equal y squared. All right, let's let x equal y squared. So therefore, what I'd get is from n equals 0 to infinity of c sub n times y squared n. All right, I did a direct substitution, and we're going to say that has a radius r. Okay, therefore, then what we would know is that the absolute value of y squared would have to be less than r. Therefore, y would have to be less than the square root of r. And therefore, the following series, n equals 0 to infinity of c sub n, y to the 2n, converges when y is less than the square root of r. Therefore, the radius of convergence for that would be the square root of r. All right, that's it for radius of convergence and interval as well. We'll do some practice problems in tomorrow's lesson, so there will not be a video on that, but hope this went well for you. See ya.